So it says we can use technology to graph more complex polynomials. However, we have to use what we know already to complete the picture. So what I mean by that is if you have this quadratic, maybe it's negative 2x squared minus 7x minus 4,271. If you just graph this and hit zoom 6, you're not going to be able to see it. It's going to be a blank window. So what do you need to do to figure out how to change the window? Because the calculator only helps you if you can figure out where the polynomial is at. So based on the test we just took, this is a quadratic in standard form. What does standard form tell us really easily?
The y-intercept.
Yeah, for sure, the y-intercept is negative 4,271, right? So we know for sure something's happening way down here at negative 4,271. What else do we know about this parabola? The 7 doesn't really tell us much, but what about negative 2x squared? Well, we know it's a parabola, but what about the negative?
Which way it faces?
Yeah, the negative tells us that it's upside down, right? So not only is it way down here at negative 4,000 something, but it also opens down. And if you didn't know that, you'd probably spend 15 minutes trying to wiggle the window around trying to find out where it's at. So you still have to use the knowledge from the test we just took to find out where it's at first before the calculator can even help you. So we've talked about moving the window. I'm going to skip that. Okay, this is the first question on your actual notes packet that you got from last class. So this is right after the warm-up. Okay, we're going to real quick make notes of how you find these things. So if 2 weeks from now you're trying to find the x-intercept, you remember what buttons you need to push. So, first of all, how would I type in an equation on the calculator? What button do we hit? Y equals. So we're just going to take a few notes real quick so you have these marked down. Now, what is the chain of buttons that I need to push to find the x-intercepts?
Second, trace.
Second, and then trace. And then what word is a synonym for x-intercept? Zero, which I think is option 2.
Yes.
Right? And then it's going to ask you your left-right guess. Okay. What about the y-intercept? Now, technically, in this case, we already know the y-intercept. What is it? It's 6, right? But if it's not in standard form, or maybe it's a more complicated polynomial, what did we push?
Trace.
Plain old trace. Not second trace, just trace. And then you can type in any x value you want. So if you type in x equals 0 and then hit enter, it will tell you the y-intercept. So make a note of this in case you forget. Last class we talked about finding the min or the max, so the hills and the valleys. So what do we hit?
Second trace.
Second trace, and then what are we selecting from that menu?
Max or min?
Yeah, whatever one you're trying to find, right? If you're trying to find a hill, you would select the max function. If you are trying to find a valley, you would hit the minimum function. And then have I shown you the table before? I think I have. Hit second graph.
Oh, yeah.
Second graph. It'll give you a table of values, like an input-output table, right? Of all of the points on that graph. And that would have been really helpful in the last test, huh? That's why I show it to you now. Yeah, me too. All right, it says, using your graphing calculator, find the following important features. So we've got a pretty big polynomial here. Do you guys remember how to name this one? X to the 5th power is a quintic, and then that's a lot of terms, that's 6 terms. So quintic polynomial, right? So first of all, let's talk about the things we do know about this polynomial already. What's one thing that we do know already? The y-intercept is 18, so that could help you maybe if you need to find a window. And then furthermore, this is a positive leading coefficient, and the degree is 5. Odd, right?
Yes.
So what do we know the ends of this, the arrows at the ends of this graph we're going to do?
Starts at the bottom.
Yeah, starts at the bottom, and we end up at the top.
And
so all of that information can help you figure out the window. So what I want you to do is find the zeros. That's what are the x-intercepts. We'll talk about the multiplicity in just a second. We'll go over that. But you can also find all the local minima and maxima. So those are the hills and the valleys of the polynomial. Okay, so go ahead and take a second and find all of those, and you can write them on your notes. I want you to round everything to the 100th. All right, we've already found some of them here. To find the hill, we're going to hit maximum again, and this time we're going to find the top of this big hill. So if you go to the left of it and hit enter, and then you can see it has to go to the right of it, to go over the hill, over the top, to the right side of the hill, and then guess in the middle, hit enter one more time. You can see it tells you the very top of that mountain is about 1.30, comma 50.45. Do you guys remember what multiplicity means?
How many times it does something?
So let's review from the test we just took. So if I gave you something like this on learning target 2 on the test we just took,
The multiplicity is 3.
what is the multiplicity of this factor? It's 2, because it's squared, right? What is the multiplicity of this factor?
Oh no.
There's only one of them. Now, what's the importance of that? What if a factor has a multiplicity of 2? What does that mean about the graph? Yeah. So what would the x-intercept be from this factor? -2, which means when you came to that x-intercept, the graph would bounce off of it, right? So we're going to do this backwards. Could we actually figure out the factors? This is not factored, right? Without having any knowledge of how to factor, could we now factor this based on the information that we have? Do we have the x-intercepts? Can we see if they're bouncing or not? Yeah. So let's factor this polynomial. Make a little bit of space up here. So, if the x-intercept is -2, what's the factor? +2. Did that x-intercept bounce? No. So if you look back here, that x-intercept -2 did not bounce. Okay. The next x-intercept was -1. So what's that factor? +1. And notice, look at 1. Does it bounce?
Yes.
-1. Yeah. So we would square that factor. And then the last x-intercept we have is 3. So x minus 3. And does this one bounce?
Yeah. Hit it with a
Squared.
Yeah. Whoa squared.
And one more thing, it starts at the bottom
And
and ends at the top. So should it be a positive or a negative in front?
Negative. Positive.
Starts at the bottom, ends at the top would be positive. Now really the only thing we don't know is the a value. Like if there was a 2 or a 3. We know it's positive. We don't know the exact a value, and that's not a big deal. But you can see, we can kind of at least already see the factors based on the graph. Without even having any idea of how to factor, you could do that. Okay, so the next one here, I'm going to skip this actually. Let's go to example 4. Everyone find example 4. We're going to start relating this information to some scenarios. Hang in with me, make sure your phones are not out in the middle of my lesson. That is rude. And let's talk about this situation. It says Miguel throws a ball straight up into the air and then lets it fall to the ground. The graph shows the time in seconds along the x-axis and the height on the y-axis. So what is the x-axis telling me? Time. Time, right? In seconds. What is the y-axis? It's height. So what doesn't really make sense?
That goes below the x-axis.
And does negative time make sense?
No.
No. And does so if we're throwing a ball, so you can kind of see here, where does the ball start at 0 seconds?
It would start at 5.
Looks like it's at 5, right? So if you think about it, it's kind of like Miguel is holding the ball. Does it make sense that it's about 5 feet high? Yeah, so let's say it's a football. It'd be right around where his head's at, right? And then he throws the football, and then what's it going to do?
Make a parabola.
Gonna make a parabola. We saw that on Mark Rober's video last class.
Sure.
So where is the ground? The ground is the x-axis, right? So this is the ground. Does any of this really make sense down here?
No.
No. So you can kind of see in like a real world situation, certain parts of the parabola might not make a ton of sense. So we kind of isolate the parts that we need, which in this case is everything in quadrant 1. So all of this we can basically ignore. Okay. So let's go and answer these questions real quick. What is the y-intercept? 0, 5. What is the vertex? 2, 9. What are the x-intercepts?
-1 and 5.
Negative 1 and 5. I'm just going to list them since this isn't a very... So x equals -1 and 5. We don't have a ton of room there. And what is the AOS?
2.
X equals 2. Now we're going to try and figure out what does this mean. So what does the y-intercept mean in the concept of this problem? Yeah, when time is 0, how high is the ball? When time is 0, how high is the ball? 5, right? We call this the initial height. Basically, when 0 seconds have passed before the ball is thrown, how high is the ball? So you can see it starts at 5 feet in the air. Now, what does the vertex mean? It kind of means two things. What does the 2 mean?
That's the
2 seconds. After 2 seconds, how high is the ball? 9 feet. Yeah, what is that? It's the what, Tony? It's the maximum height of the ball. So at 2 seconds, the ball is at its maximum height of 9 feet. Now, which x-intercept doesn't really make sense? Yeah, so we basically ignore that. But what does this x-intercept mean in the concept of the problem?
When it's the ground.
Yeah, it's when the ball hits the ground. So at 5 seconds, how high is the ball? 0 feet, right? 5, 0. So that's when the ball hits the ground. And what does the AOS tell us?
The height.
Yeah, kind of. That's where it changes from increasing to decreasing, right? So I've asked you that before on tests this year, right? What are the increasing intervals? When are the decreasing intervals? So from what seconds, how many seconds does it take to increase?
2.
Yeah, from 0 to 2 seconds, the ball's going up, right? And then it starts decreasing from where to where? 2 to 5, and then it hits the ground, right? So at that point, we'd stop. So I've asked you that on the test. You can kind of see that. It makes a lot of sense in this case because the ball is literally going up and coming back down. Okay. Now, the last thing, what do these points mean? The 0.18 and the 0.38. Here's the 0.18. Here's the 0.38. What does that tell me? At 1 second, the ball is 8 feet high. At 3 seconds, the ball is... So how many times was the ball 8 feet high? Twice. On the way up and on the way down. It happens twice, right? So I might ask you on a test, at what times was the ball 8 feet high, and what would you say? 1 second and 3 seconds. Happens twice, right? Up and down. Okay. So let's look at this last problem for today. It says a rock is launched from a slingshot and follows the trajectory modeled by the function, and then you can see we have a little quadratic there, parabola, where x is seconds and y, or f of x, is height in feet. So based on what we just talked about, you should be able to answer these questions. So I'm not asking you anymore, what's the y-intercept? What's the x-intercept? Okay? You have to read the questions and understand, oh, well, that must mean the x-intercept. Or, oh, by asking that, they're asking me for the vertex. Okay? So for the next 10 minutes or so, go ahead and answer each of these questions, and then you can obviously use your calculator. That's kind of the point here. But now you have to interpret the part that it's asking. It's not. I'm not just blatantly asking you the questions anymore. Okay, so go ahead and take a little bit of time and work on that, and then we'll go over the answers here in just a second. So here's the parabola. Obviously, the window needs to go up. Who has a good window? Do you want to figure out how high the parabola goes? 70?
7.
Is that where you put your window at?
Yeah.
70. And I'm going to trim some off of the x-axis, so I'm going to make this like -5 and 8. You could even maybe do a little bit more, but at that point you can see the full parabola. And if you wanted, like I said, the y-axis looks really bold. So if you change that y scale to 10, then it counts by tens. And it shows you. So now the notches are by 10. It kind of cleans up the y-axis. So that's a pretty good window right there. You should be able to answer all the questions from that window. All right, I'm going to start going through some of these to find the what. Okay, so when it says the initial height, what am I trying to find on the graph? The y-intercept. So if you hit trace 0, it's 6. And we actually knew it was 6 already from the equation, right? So the initial height of the rock is... Now, does it make sense to say 0, 6?
No.
You have to kind of know, like, you need to answer the question. So if I ask you, hey, how high is that hill over there? Would you say, parentheses 0, 6, parentheses? No, you'd probably say 6 feet. So answer the question the way that you would answer it in real life. So 6 feet would be the best answer there. Okay, at what time was the rock at its highest point? What is it really asking you to find? Yeah, it's basically the AOS, right? It's the x value of the vertex. So second trace, which one of these are we selecting? The maximum. So you got to go left, and then go right, and then guess in the middle. So what is the answer to the question? Yeah, about 1 point, if we're going to the 100th, 1.94 seconds. It's only the x value of the vertex that answers that question. Time is the x. But then look at the next question. What was the max height?
66.06 feet.
Yeah, so 66.06 feet. X is time, y is height. After 2.3 seconds, what was the height of the rock? What's a really easy way to do this? So basically what I'm asking you is f of 2.3, right? You had a couple of these on your last test. So it's saying when x, or when time is 2.3, what is the output of the function? So if you hit trace 2.3, boom.
But it says af 6.3.
63.96. 63.96 what? Feet, right?
Yeah.
So 2.3 seconds, it's 63.96 feet. It's saying after it's gone for 2.3 seconds, how high is it? And last, after how long did the rock hit the ground? Ultimately, what's that asking you to find? The x-intercept. So second trace 0, option 2. And then we do it the same way as the min or max. It says go to the left of the x-intercept, so hit enter. And then go to the right of it, which is kind of below. And then guess, kind of come back to the middle there and hit enter one more time. So what is my answer?
3.4.
About 3.97 seconds. Good. So you can kind of see how the calculator can help us out, right? That would have been a lot of work to do manually if I asked you to find all this on your own. But once you get it graphed and once you get a good window, the calculator can be very, very helpful, especially for these answers that are kind of ugly decimals. Okay. All right, that is all for today.